We're going to start with chapter 2 as a review of basic chemical structures and ideas that are going to apply to human anatomy and physiology. So you may have had chemistry before. If you have, that will help you. But there's some important concepts that we need to make sure you know. The majority of our body is going to be composed of these 4 elements: oxygen, carbon, hydrogen, and nitrogen. And then we also have some other elements that are important: sodium, potassium, calcium, and zinc. And as we go through the semester, you'll see how these play an important role. But understanding how these molecules work together is the basis of A and B, and understanding how our bodies work. Let's look at these molecules. I'm talking about different molecules and how they work together. So let's look at the basis of these molecules. They're composed from atoms. And then, of course, we have the periodic table of the elements, which are basically different forms of atoms. And so all matter is composed of these elements, which is why we have the periodic table. And elements are these substances that can't be broken down any further, or into any simpler substances by ordinary chemical methods. You have to use a subatomic particle breaker to break these down. Okay, so there's no chemical methods to break them down any more simply. Again, to review the elements of the human body that are essential and actually compose about 96% of our entire body are going to be these 4: oxygen, carbon, hydrogen, and nitrogen. And you're going to see them all semester. About 4% of our body mass are these other elements that are much less common. So calcium, phosphorus, potassium, sodium, chlorine. Just because they're less common doesn't mean they're any less important. Specifically, what we're going to see is how these 3 have a huge role in specifically our nervous system, our skeletal system. So even though they're in smaller amounts, very important. And then there's a very, very tiny or trace amount of things that make up our body mass, which are considered parts of enzymes. So chromium, manganese, zinc. So there's those elements in just trace amounts. Here is a table that you can use to reference just to see about how much each of these elements contribute to our overall body mass. Oxygen, of course, is the most. Carbon contributes the second most, then hydrogen, followed by nitrogen. Let's look at the atoms that make up the elements. And why is it important to know what atoms or how the atoms are designed and laid out to make up these elements? It's important to know this because there are properties of how these atoms are arranged to make the elements that make those elements have characteristics that are beneficial for certain situations or not beneficial for certain situations. So how they're made or how they're structured is super important in understanding how these elements work. So all of the elements are made up of atoms. Again, atoms are going to be the building blocks for each element. It's going to give each element its particular properties. And when we look at elements, it's arranged or written in the periodic table with certain symbols so that we can have quick notes, so to speak. This letter right here to the top left indicates the mass. How many protons and neutrons does an element have? This is the atomic number. So here we have, in our example, we have C14-6. So this is carbon, and it has a mass number of 14, and its atomic number 6. In our periodic table, sometimes we see this, and this is actually just an average of weights or masses, I should say, and we'll talk about that in a minute.